Hello, I am Bruce, and I'm a systems engineer at Fred Hutchinson Cancer Research Center, where we conduct research to the highest standards to improve the prevention and treatment of cancer and related diseases. We also have an infectious disease wing, which is actively participating in the fight against COVID-19. I'm really excited to share with you guys how this conference assisted me over this past spring in this fight against COVID-19. Currently, I'm an active member of the Mac Admins of Seattle meetup. We meet virtually every Thursday on Zoom or hashtag Cascadia on Slack. And there we really like talking about e-bikes. So my talk, CPEndgame. Client platform engineer seems to be the common job title some of us have. And Endgame was a blockbuster movie hit called Avengers Endgame that released sometime last year. And for those that are not into superhero movies, the premise is there's a big purple guy that wants to collect a bunch of magical stones. And in this case, for me, it'd be Apple security stones to eliminate half of humanity. It's kind of heavy right now. Endgame is the culmination of all these crazy stories. And with our industry constantly changing, what is the end game for a CPE? And selfishly, what I discovered during this conference, what is my career end game? For some reason, someone decided to take a picture of me at Hack Night. MacDevOps was my first IT conference, and I had no idea what a Hack Night was. I thought we were going to get like a project, and we were going to compete against each other. I had really no idea. I ended up learning about Monkey and Monkey Report, and that was really cool. At this point, my technical chops were, I just left the help desk to become a Jamf admin. And for those who are not familiar with Jamf, that just really translates to I get really excited to write short shell scripts to perform functions that Jamf cannot. So in this room, I felt like a fish out of water. So because I was uncomfortable, I chose to sit at a table next to the TV where the NBA Finals was playing. And I thought that was cool because a Canadian team was playing and we were in Canada. Little did I know, the person who manages and runs the biggest open source platforms was also a rabid NBA fan. And he sat down next to me. And as the night progressed, this happened. So these are the people sitting around me. As people begin to talk shop, I'm starting to realize what projects people participate in. And the person who sits next to me ends up using one of the first tools I ever used for Jamf when I was at Jamf Tech, AutoDMG. And I got super excited. And I wanted to tell him, like, oh my God, I'm such a big fan of your work. You've had such a great effect on my career, yada, yada, yada. And I realized, no, that's embarrassing. Don't do that. Why would you ever do that? So instead, I'm telling the hundreds of people on Discord this embarrassing story. I go around the room looking at all these people contributing to projects that I use on a day-to-day basis. You got Auto Packager, MS Update, Mr. PHP Report, Monkey, AutoDMG, who offered me some Swedish fish, and I guess the project Outset. So here I'm starting to have like a crisis of what do I contribute? Where is my career headed? What can I do to contribute? And where is our field headed? So I put my thinking cap on. So take out my crystal ball and try to figure out the end game of my IT career and how I can adjust what I do on a day-to-day basis for when our field changes. I will be ready to move into a field more related to where we're headed. And I feel like Apple's been dropping hints on where our field is headed with these security gemstones. And I don't think I'm the only person with this feeling.
Here, we can put Managed Software Center here, we can draw a line of best fit, and oh my God, it's going to take well over a year. Will we even still be able to use third-party tools to manage Mac OS updates by the time, in a year and a half, by the time 10.16 ships? Do I want to spend a year on that bet?
So a prominent person in the community also thinks our field is changing, and I actually agree with him. I really do not think a couple years from now we're going to have third-party configuration management tools. So security gems. So as I mentioned earlier, the Avengers movies were based off this evil purple man collecting these stones to eventually put together a glove to destroy humanity, or in my opinion, configuration management. And we'll go over them real quickly. This is a very Mac-savvy room, so we're not going to dive too deep into these. I just kind of want to run into some themes. 32-bit app support. That was around High Sierra, I believe, and it was officially dropped 2 years later in Catalina. We have Apple smartly kicking developers out of the kernel. I feel like we started getting nag screens maybe a year ago, maybe during Mojave, and that I feel like it's getting dropped with this next release this fall. We have the read-only file system, which comes from, we've come a long way from SIP. We have universal logger as we push people away from using syslog or ASL. We have notarization, which I believe was mentioned in WWDC about 2 summers ago, and finally this February got implemented. So I feel like the remaining stone that is like the defining moment in our careers as sysadmins or Mac admins is a stone that was found last month. So what is a security update? We get them all the time. Why is that even a big deal? Call this out. The last line's a big one. The ability to ignore individual updates will be removed in future releases of macOS. If you were to traverse the internets, you're going to see a lot of angry people, a lot of Jamf Nation, Google, Mac subreddit. People are not thrilled. I'm sure there's going to be a lot of angry radars, and those radars are going to force Apple to backpedal and maybe create like a 90-day pause feature. I'm not sure how that backpedal is going to work, but generally they will. But I will also say, if we look at the security stones from a couple slides earlier, in 2 years, this is gone. I really believe within 2 years, our MacBooks are going to patch on our own. We will have zero control of them. It'll be very similar to an iPhone. I'm not one of those people that thinks iOS and macOS are going to merge by any means, but I do think updating your computer is going to be taken out of our hands. And actually, I think that's a great thing. One of the most common sayings in DevOps, and if you notice, this conference is called MacDevOps. The most common phrase is pets versus cattle. And as you can see here, I have a nice little description of both pets versus cattle, and we are pro-cattle. So to describe this further, in the old ways of doing things, we treated servers like pets. For example, Bob the mail server. If Bob goes down, all sysadmins hands on deck. If the CEO can't get his email, it's the end of the world. In the new way, we have servers that are numbered, like cattle in a herd. For example, email 001, and we'll have 50 more to email 0050. And when one goes down, another replaces it. That's the idea of DevOps. I think if you look at the image I present, at the bottom, we have golden image versus provisioning. I think Apple's been ahead of this cattle game for a while, and I didn't even realize it until I was putting together this presentation. We all know imaging is dead. There's no longer the time where you build this image, this golden image, with all this custom software settings to deploy to your fleet for like specific departments or employees. We provision now. We use Apple Internet Recovery, and what that does is it gives you the most modern, secure operating system for your Mac. It doesn't matter who you are. I remember the days when I first got into configuration management. I always wanted to like change the background or do other silly settings like that. The hubris to think that just because you're able to control something, just because you have power over it, doesn't mean you should. And looking at the chat, I'm with you. I work at a nonprofit research center with scientific applications during the Catalina release. I feel the pain. It's just, I don't know why the pain has to fall on us. I believe one of the big tenets of DevOps is application support should go on the vendor and not the sysadmin. With this talk, I'm going to be talking about building Windows infrastructure with Linux tooling at a Mac conference. That's different, but we're in the middle of a crisis and an epidemic, so roll with it. What I learned last year at MacDevOps, the 3 videos or conference talks I liked most were the PostLab story, which involved GitLab. It was very unique on how he deployed video versioning control. And the way I interpreted that, I was like, what can I use with my GitLab environment back at work? How can I take what I learned from him back home? And I ended up creating an inverse Jamf version control called JSS Backup, where every night I scrape the API and commit it to a repo. So every time something is changed in Jamf, those changes are then committed to GitLab. So I have a daily version control of my Jamf Cloud setup. I also watched a talk by Greg Neagle about converting Python to Swift. And that made me realize the fact that I was only pretty much just a script kiddie in shell, that I needed to up my programming. So I wrote my first Python script that scraped my Jamf API and put all my macOS endpoint data in the Elk stack. So it'd have historical endpoint data to look at, something that Jamf currently doesn't offer. And then most importantly, the biggest talk, the talk that I appreciated the most was there was a Terraform talk about building Monkey in 3 minutes or less. And as an infrastructure person, that spoke to me. And I immediately went home and started Googling, researching, practicing Terraform. I became obsessed with the program. And what I ended up doing was building a workflow that builds Windows 2019 into our server environment. Currently at Fred Hutch, the way we build a Windows 2019 server is through, unfortunately, SCCM. So the way that works is you build a VM into vSphere. You go through all the tedious settings. You find the MAC address. Then you log into SCCM. You take that MAC address and put it in I think it's called not a security group, a collection that gives it PXE booting availability. Then you go back to the VM, you attempt to PXE boot into something and that's you're running through a browser, and then you go through these steps, watch it build for hours. It takes the whole afternoon and I hated it. It was one of my least favorite things to do as a system administrator. But after watching that talk by, I believe, Graham, I was like, Terraform can do this, and they could do it very quickly. So now I was able to build a Windows 2019 server in 5 minutes and 45 seconds. I think that's super cool. What's not cool is convincing everyone else infrastructure as code principles, especially when you're the junior on the team. It was very difficult to get buy-in, and I believe we even had to talk about that last conference about open source is hard. And I oh my God, it is so hard. And the reason I was drawn to this is DevOps and Windows do not go hand in hand. DevOps and VMware do not go hand in hand. If you wanted to learn Terraform, you will find 1,000 tutorials online about putting an Ubuntu server into AWS. So I really enjoyed building something that at the time wasn't even in GitHub. So let me set the stage. Early March comes around. My SCCM admin decides to perform SCCM maintenance. And that next morning, we can no longer provision Windows 2019 servers for whatever reason. And it's early March. So think of the news then. We're all getting sent home, and I have .NET developers asking me for a Windows 2019 server so they can build screening apps so people can get back onto campus. And my team can currently not build a Windows server. So Terraform jumps in. I'm finally saying, I have the solution. No one else has the solution. Let me build this server. And I was able to build it in 5 minutes. So what is Terraform? From the website, Terraform is a tool for building, changing, versioning infrastructure safely and efficiently. Terraform can manage existing and popular service providers as well as custom in-house solutions. But in my opinion, it's just an open source infrastructure provisioning. I love that. It can hook into many, many platforms. That's why I love open source. It uses a declarative language, and it's kind of uncomfortable for me to tell some of you what a declarative language is, but kind of picture it like an imperative language. If you're trying to drive somewhere, you follow directions, you go down different routes, maybe you follow a map to get to the end goal. Declarative language, I just call it Uber and I just magically, Lyft, just appear somewhere. I like that coding style better. And there's just 3 main phases of Terraform, and it's super simple. You build your code block, you plan your code, you apply your code. It's very, very simple. Code, plan, apply. When you're coding, there's 4 major types of code blocks. You have your providers. A provider is what does the API calls to whatever infrastructure you're trying to build into. Currently, we're trying to build into VMware, so we're going to use the vSphere provider. Data sources are objects you're trying to get info on so you can use later. So you're going to want to know what network you're using or what data center you're installing into. Resources. That's the name of the game and the fun part. You define resources so you can build them later, like the name of your VM, how many CPUs you're using. And then provisioners. I'm sure we're all familiar with Chef, Ansible, shell scripts. Terraform, provisioners kind of dive into configuration management well, so Terraform kind of recommends against you using them, but sometimes you just need to use some sort of configuration management to say, join something to the domain. The plan phase is where you test your changes. It tests desired state versus what currently exists, and then apply just does the thing. It will just build the resource. So let's first talk providers. So the provider we're using is vSphere to build this COVID-19 fighting machine. The VMware vSphere provider gives Terraform the ability to work with VMware vSphere products, notably vCenter and ESXi. Essentially, it just authenticates to your VMware center and uses APIs to build things. And the code block to the right is how you would set up that connection. There are some problematic entries with that code block. That's from their official documentation. I don't think I need to tell you guys. Plain text passwords and code allowed unverified SSL. That's a completely another talk that someone's probably more capable of talking about. But to hook into vSphere, it's just 4 lines of simple code. Data sources. This here will define data sources. Data sources allow data to be fetched or computed for use elsewhere in Terraform configuration. Use of data sources allows a Terraform configuration to make use of information defined outside of Terraform or defined by other Terraform configurations. So let's go through the code. There are 4 things we need to define. We need to define our data center. What is your vSphere called? What is its data center? And it's simply just defining name on line 2. And in this case, we're going to be using DC1. The second code block, we're going to define our data store. Where are the bits? What hard drive or RAID array is it installing onto? So most data centers have multiple data stores where you can install things. So again, you just define the name of whatever data store you're installing into, and it knows what data center to go into. So if you look 1 line below that, where it calls out data.vSphere_datacenter DC. And then the line before that is where we define the resource pool. Resource pool, usually companies have multiple resource pools, some for production, some for dev, some for tests, and it can allot resources appropriately. So here, ideally, because we're making a COVID-19 fighting machine, we'll define the name of the resource pool as something production related to get that extra oomph. And then it's got to go on a network. So for AWS people out there, it's kind of like maybe creating a VPC, but we have to define which network it can go on. So we can get a DHCP IP or maybe assign it a static IP, and that's where we define the network in that 4th code block. The next set of code is called resources. We need to define resources. Resources are the most important element in the Terraform language. In my opinion, the most fun. This is where you get to feel like a master of, an orchestrator of code and building objects. Each resource block describes one or more infrastructure objects, such as virtual networks, compute instances, or higher level components such as DNS records. So here, we're going to build a resource, and the resource we're going to build in this case is a VM. And as I get better and we learn more, you can build more than just VMs. You can build tons of infrastructure. You can make DNS records. You could hook into any environment that you have at your availability. But here we will be building a virtual machine, i.e. a VM. And I took this off their documentation, but we would use, instead of Terraform test, we would call it, let's say, COVID-19 fighting machine. And you can see it's going to start calling those data sources we defined earlier. Remember when I was talking about resource pool? We're going to build Terraform test or COVID-19 fighting machine into the resource pool we defined earlier, called data vSphere_resource_pool. And then the fun begins. We can start beefing up our machine. We can give it as many as CPUs as we want, 1 to 4, whatever your environment has to offer. We can increase the RAM from 1 gig all the way up to 16. We're going to define the network interface. And at the very bottom, we're going to define the size of the hard drive. So here it's 20 gigs. We would probably give it more, and we wouldn't call it disk 0 because we're going to be on a Windows machine. We would call it maybe Windows or hard drive. And lastly, provisioners, which are okay. They run sequential and they only run once on build. Provisioners can be used to model specific actions on local machine or on a remote machine in order to prepare servers or other infrastructure objects for service. So the 2 I routinely use is remote exec or local exec. And what that means is running a piece of code locally or on the thing you're building. And if it's Linux, it's SSH. And if it's Windows, you're using WinRM. And the way I use it is I'm a Ansible shop, and I use Ansible to bind my servers to the domain. But because Windows servers take so bloody long to build, unlike Linux, and if you remember, Graham built his machine in 3 minutes, I'm going to build mine in like 6 or 7. I can't have Ansible trying to log into a Windows machine that's not ready. So what I do is I create a PowerShell script that remotes into the machine just to say, hey, I'm done. And when that is finished, then I know my local Ansible playbook can run. So the next phase is Terraform plan. Terraform plan command is used to create an execution plan. Terraform performs a refresh unless explicitly disabled, and then determines what action to achieve the desired states specified in the configuration files. So what that really means is it looks at where it's building, the desired state, and it looks at what you have, and pretty much just does a diff. And then it presents that diff in the screen on the right. And the most important line is plan 1 to add, 0 to change, 0 to destroyed. So it knows the desired state is empty, and it's going to take the code we just filled out earlier to build the thing. And that's it. That's all it does. It doesn't do anything else. You can't break anything. It's just verifying connectivity and your code, syntax, making sure everything's right. And you should always plan before executing. And if you want to get really DevOpsy with it, you can commit your plans to a GitHub or GitLab repo and have it locked behind approval, where you can have a coworker go over your plan, i.e. your code, and see what's changing, and then approve or deny those codes. And then there's apply. The Terraform apply command is used to apply the changes required to reach the desired state of the configuration, or a predetermined set of actions generated by the Terraform plan execution plan. So to the right, you can see what's happening. It's going to show you the same group of text, the plan, and say, hey, this is what we're going to do. We're going to add these resources. And you say yes or no. And you say yes, and it's just off to the races. And then the apply completes, and you have a resource added, and you're done. That's it. You've built a Windows 2019 COVID fighting machine. So we have a demo. But before we start the demo, I'm going to scroll through the Discord and see if there's questions, or ask questions now. All right, we'll get going. All right, so first, when you pull down your code from whatever repo you're using that has your Terraform code, this is what I use. This is my setup. We have hosts, main TF, Terraform TVARs, and variables TF. Variables TF just declares all the variables we're defining. That's it. It's a very simple file. Moving over is Terraform TFVARs. That's where I define my variable. So like if I want memory 8 gigs, that's where I'm declaring it. If I want 2 CPUs, if I want a Windows name, I define all my attributes in Terraform TVARs. And then main TF, one over, is the crux of the code. That's where all the code we went through all those slides, where that's where that code lives. You generally don't, the way this is set up is you generally don't change that code. The only thing you're going to change is your variable definitions in Terraform TFVARs. And then we have the host file. So Terraform can pass variables. So the way this is helpful for me is, let's say I define the IP to whatever I want it to be. I can pass that IP into the host file. And then when I run my Terraform playbook, I can read that host file. So essentially it just echoes an IP into the host files. But that host file is currently blank. It will be written to during the demo. So what happened there? We did Terraform init. All Terraform is making sure it's installed. The provider you're using, in this case vSphere, is initialized and ready to use. That's it. So we did a Terraform plan. So Terraform just went through my code and found all of my variables and decided and saw my desired state that I couldn't find anything. So it's going to build. And as you can see, it goes plan 1 to add. It's a very important and an intentional line when you're using Terraform, is see what it's doing. Is it adding, changing, or destroying? And we are adding. So that's great. And I like what I see. So we're going to run it. Are we sure we want to do the thing? Yes, of course we do. Let's build the COVID-19 Windows server. So because this is Windows, we're not going to watch a shell screen for 5 minutes. Generally, it takes a minute just to boot up. Then it restarts itself around 2 minutes. Then it starts performing modifications around 3 minutes. And then at 5 minutes, it's finished, usually. And then the Ansible playbooks start running. But I'm not going to make you guys sit and watch this for 6 minutes. So that's it. I really appreciate, this is my first conference talk. I was very nervous. I really appreciate Matt letting me speak to y'all. I just thank you.